Welcome back to Kamal Kunj Home Academy Encounter with Mathematics. In this session, we will discuss a theorem on solution of simultaneous linear equations in two variables. Now first we will discuss the theorem, then solve the problem. Now the theorem is system of simultaneous linear equations a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1 upon a2 is not equal to b1 upon b2. As unique solutions. Solution. Now to prove the unique solution of above system of simultaneous equations x equal to b1 c2 minus b2 c1 upon a1 b2 minus a2 b1 and y equal to a1 c2 minus a2 c1 divided by a1 b2 minus a2 b1. Now we have to prove that the solution of this simultaneous linear equations will be this way. Now proof. Here equations are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Let this equation be 1 and this 2. Now multiplying equation 1 by b2 and equation 2 by b1, we get a1 b2 x plus b1 b2 y plus b2 c1 equal to 0, and multiply second equation by b1 becomes a2 b1 x plus b1 b2 y plus b1 c2 equal to 0. Now subtract. This will cancel out. So here it is a1 b2 minus a2 b1 x plus b2 c1 minus b1 c2 equal to 0. This implies that a1 b2 minus a2 b1 x equal to b1 c2 minus b2 c1. And this implies that x equal to b1 c2 minus b2 c1 upon a1 b2 minus a2 b1. So this is the value of x. Now for finding the value of y, multiply this equation 1 by a2 and 2 by a1. Multiplying equation 1 by a2 and equation 2 by A1 and then subtracting we get, if you multiply this equation 1 by A2, it becomes A1 A2 x plus A2 B1 y plus A2 C1 equal to 0, and multiply second equation by A1. It becomes A1 A2 x plus A1 B2 y plus A1 C2 equal to 0. Now subtract it. So this is cancelled out. So here we have A2 B1 minus A1 B2 y equal to this plus A2 C1 minus A1 C2 equal to 0. This implies that A2 B1 minus A1 B2 y equal to minus A2 C1 minus A1 C2. This implies that y will be equal to minus A2 C1 minus A1 C2 upon A2 B1 minus A1 B2. This is equal to A1 C2 minus A2 C1 upon A1 B2 minus B2 C1. So x equal to itna and y equal to this one. Now we will solve this equation, simultaneous equation. A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus A2 equal to 0. We compare this equation by this. Given equation is twice x plus 5y equal to 1 and twice x plus 3y equal to 3. Now this can be written as, this implies that twice x plus 5y minus 1 equal to 0 and twice x plus 3y minus 3 equal to 0. If we compare these simultaneous equation with this one, here we get A1 equal to 2, B1 equal to 5 and C1 equal to minus 1 and A2 equal to 2, B2 equal to 3 and C2 equal to minus 3. So x is equal to, we know that x is equal to B1 C2 minus B2 C1 upon A1 B2 minus A2 B1. Now put the value of B1 here is 5 and C2 is minus 3 minus here B2 is 3 and C1 is minus 1 divided by A1. A1 is 2, B2 is 3 minus A2 is 2 and B1 is 5. This is equal to minus 15 plus 3 upon 6 minus 10. This is equal to minus 12 upon minus 4 equal to 3. So x is equal to 3. and y is equal to A1 C2 minus A2 C1 upon A1 B2 minus A2 B1. Now here A1 is 2 and C2 is minus 3 minus A2 is 2 multiply C1 is minus 1 divided by A1 is 2 and B2 is 3 minus A2 is 2 multiplied by B1 is 5. So this is equal to minus 6 multiply minus 6 minus plus 2 divided by 6 minus 10. This is equal to minus 4 upon minus 4 equal to 1. So solution is x equal to 3 and y equal to 1. And this method of solving simultaneous equations in two variables is called method of cross multiplication. To remember the solution, you can, with the help of diagram, here x, y and 1. B1, B2, C1, C2, A1, A2 and B1, B2. Cross multiplication, this is multiplied by this minus this minus product of this so this implies that x upon B1 C2 minus B2 C1 equal to y upon C1 A2 minus C2 A1 equal to 1 upon A1 B2 minus A2 B1. Now with the help of this diagram, you can remember the solution of x and y. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.